Welcome to EDU World Space.
In problem 78, we have a screen, which is given over here. This is the screen. And then we have an object given green. And the object and the screen are basically in the same distance away from a converging lens. And 60 centimeters away from this object and screen is a flat mirror, right? And then in between them somewhere, there is a converging lens that's placed. And we're told that at 22 centimeters from the object, when we place the converging lens there, then the image that's reflected of the object that goes through the lens and then is reflected back from the mirror is sharply focused on the screen. So it's sharply focused on the same spot where the object is. And in part A, we were asked to draw a diagram indicating basically what's going on. So right away from knowing that the object and the mirror are 60 centimeters apart and that the lens is 22 centimeters from the object, we can find out the distance between the lens and the mirror, which is nothing more than the difference between the distance from the object to the mirror minus the distance from the object to the lens. So that gives us the distance from the lens to the mirror. And we'll need this number. So I just kind of drew it in, and it's 38 centimeters when you take the difference. And now for this converging lens here, we have an object, and what will happen when it goes through, when the light passes through the lens from the object, which the distance is given by S1, which is 22 centimeters, there's an image that is formed by this converging lens. And I've denoted the image that's formed by the lens of this object by S1 primed. Now, so that's the first thing that happens. Now, the next thing that happens is that this image now becomes the object for the mirror, right? So now we have we have over here at S1 prime, the distance between, let's say the mirror is placed at some distance SM over here. So now this object is SM away from the mirror, and it'll form a reflection that's pretty much equidistant, the same distance SM, which I call SM prime. So right away, because it's a plane mirror, we know SM is equal to SM prime, right? Okay, and now what will happen is that this lens, because the light is being reflected back through, will see effectively an object now, right, that's at S2. So then S2, where we have S2 is S1 primed plus SM plus SM primed. But we know for a plane mirror that we have SM is equal to SM primed. So then we have S2 is equal to S1 primed plus 2SM. And let's just save this result. So basically, when the light is coming back now from being reflected from the mirror, the object distance is at S2, which is given by this equation here. And now the image is going to be formed at S2 prime. And S2 prime is the distance from the lens to the screen, but the screen and the object are located in the same place. So S2 prime is the same as S1 prime, which is from the object to the lens, right? So we can write here that, S1 is the same as S2 prime, okay? So these are two important, we have three important pieces of information that we're going to use in part B, which is to find the focal length of this particular lens. So let's remember we have this equation 1 over s plus 1 over s prime is equal to 1 over f. So we will apply this equation 2 times, right? One set for s and s1 prime, and again for s and s2 prime, right? So we have 1 over s1 plus 1 over s1 prime is equal to 1 over f. The focal length is obviously not changing because we have the same lens that we're using. And then again, we can apply it another time. 1 over s2 plus 1 over s2 prime is equal to 1 over f. Now, what we can do is substitute for, let's say, use this equation, right? So 1 over s is 1 over s1 plus 1 over s2 prime, and substitute for this 1 over f here. So I'll just have this 1 over s2 plus 1 over s2 primed is equal to, and I'll substitute this on the right-hand side, 1 over s1 plus 1 over s1 primed. Okay. And now we're going to use the fact that S1 or S2 primed is equal to S1. So I will okay, let me put over here. So 1 over S2 plus 1 over S2 primed is now S1. S1 is equal to 1 over S1 plus 1 over S1 primed, right? So the right-hand side, I put it over here, and the left-hand side, I replaced S2 prime by S1. And if I move S1 from this side over to the right side, right, if I subtract S1 from both sides, then that term goes away, and then I have 1 over S2 is equal to 1 over S1 primed, which tells me that S2 is the same as S1 primed. Okay, so S2 is the same as S1 primed. So let's look at our picture. What does that mean for us? So here is your S2 distance where the images as being reflected, the image that's formed by the reflection in the mirror. And we're told that, okay, that's actually the same distance as this S1 prime. So that means the mirror is really right here, right? So the mirror should be right here. And if the mirror is right here, that means SM, and therefore SM primed are 0, right? But another way to do that, to see that, like if you wanted to just use the equations, is if you substitute, we just found that S2 is S1 primed. If we substitute that in here, right? So if I substitute for S1 primed, so I use these two equations, and that tells me that, okay, S2 is equal to S1 prime, which is S2 plus 2SM. And if I move this to the left side, then I have 2SM. 2SM is equal to 0, which means SM is equal to 0, right? So what does that mean? What is SM? SM is the distance from the object to the mirror. And if that distance is 0, then the mirror and the object coincide. They're at the same location. So we have sort of a physical idea of what's going on here. And now that we have this bit of information, we can pretty much solve our problem. Okay, so how will we solve this particular problem? Well, we will use this fact that we have the distance from the lens to the mirror is 38 centimeters, and the fact that the distance of basically S1 and S2 are the same, that means the mirror is over here at S1 primed, and then DLM really, so that we said the mirror is over here, DLM is the distance between the lens and the mirror, so this distance is 38 centimeters, so that means S1 primed is the same as DLM, so S1 primed is equal to DLM, which is 38 centimeters. Okay, so now we can use this equation. So we know S1, right? S1 is 22 centimeters. We know S1 primed, which is DLM. And hopefully it was clear how I figured out that S1 prime is the same as the distance between the lens and the mirror, right? Because remember, we found that the image and the mirror location coincide. So let's solve on the next page for the focal length. 1 over S1 plus 1 over S1 primed is equal to 1 over F. And then we can, do some stuff here. So I can multiply top and bottom by S1 prime of this 1 over S1 plus 1 over S1 primed top and bottom by S1, and that's 1 over F. I'm basically just doing a procedure here to get common denominators. So then I have S1 primed plus S1 over S1 primed times S1 is equal to 1 over F, which means F is equal to S1 primed. It's S1 primed and S1. S1 over S1 prime plus S1. And I have the values for these. Let's go back to page 1. So S1 primed is 38 and S1 is 22, both in units of centimeters. So that's 38 centimeters times 22 centimeters divided by 38 centimeters plus 22 centimeters. And I'll leave it to you as an exercise to basically plug this number in a calculator, and then you'll get your final answer for the focal length.